I'd like to do an example of a mole-mole problem in stoichiometry. What we have here is a question: how many moles of zinc are produced if 6 moles of aluminum is reacted with zinc chloride? Well, the very first thing we need to do is to get a balanced equation, or get the recipe. So let's go ahead and write a balanced equation for this. I've got aluminum reacting with zinc chloride. Remember, off to the side here, let's take a look here. Zinc is 2 plus, chloride is Cl minus, so I'd need 2 of these, so that's why this is ZnCl2. For sure this is going to produce aluminum because it says, or excuse me, it's going to produce zinc because it says how many moles of zinc are produced. Taking a look at this, we can see that this is a single replacement reaction. I've got an element, aluminum, reacting with zinc chloride, a compound. So zinc gets kicked out by aluminum, and we wind up with zinc and aluminum chloride. So far we've got our formula equation. The problem is this isn't balanced. So I'm going to go ahead and balance this. Let's take a look at our zinc. We've got 1 zinc over here, 1 zinc over there. That's okay. 1 aluminum here, 1 aluminum there. That's okay. But I've got 2 chlorines here, 3 chlorines there. So that's not balanced. I can balance this up by putting a 3 here, a 2 here, a 2 here, and a 3 here. Now I've got 2 aluminums, 2 aluminums. I've got 3 zincs, 3 zincs. I've got 6 chlorines. 2 times 3 gives me 6, and 6 chlorines. 2 times 3 gives me 6. I now have my balanced equation. So I'm ready to go ahead and get started. Go ahead and take a look at the guess method here. My given is my 6 moles of aluminum. So that's my given right here. 6 moles of aluminum. My unknown is moles of zinc. So I'm ready to go ahead and get my setup going. I've got 6 moles of aluminum as my given, and I'm trying to get 2 moles of zinc. The way I'm going to do this is I'm going to use a molar ratio. So we're going to use the molar ratio from the coefficients in the balanced equation to convert from moles of one material to moles of another material, where A and B here represent 2 different materials. So back to my problem here. What I typically do is I'm looking at aluminum and zinc. So what I do is I go ahead and I box those 2 in, my aluminum and my zinc. Those are the 2 materials. Aluminum, could be material A, zinc is material B, and I'm trying to get from one material to the other. So I need moles of aluminum to cancel. So what I've got is 2 moles of aluminum, And that comes from this right here, my coefficient. So what that'll do is that'll allow me to cancel out my moles of aluminum. So on top, I'm going to go over to the other box that I boxed in. This 3 is the other part of my molar ratio. 3 moles of zinc. So that's what I'm left with. I go ahead and I do the math here. I know that this will go down to 1 and a 3, so I wind up with 9 moles of zinc. Let's go ahead and try another one. Let's use the same reaction where I've got aluminum reacting with zinc chloride to produce zinc and aluminum chloride. Mixing this up, I've got what I have here. I had a 2 here, a 3 here, a 3 here, and a 2 here. Let's try this question. How many moles of aluminum would react with 12 moles of zinc chloride? I've already got my recipe. I've got my balanced equation. I'm ready to go ahead and identify my unknown and my given. My given is this 12 moles of aluminum chloride. My unknown would be my moles of aluminum. Ooh, did I call my given aluminum? No, my given is the zinc chloride. My unknown is the aluminum. Let's go ahead and get started here. 12 moles of zinc chloride. And I want to get to moles of aluminum. Again, I'm going to box in the stuff I'm interested in, zinc chloride and aluminum. So I put a little box around that. There's my zinc chloride. Put a little box around my aluminum. And I'm ready to go ahead and create my molar ratio. Moles of zinc chloride to moles of aluminum, or moles of aluminum to moles of zinc chloride. According to my balanced equation here, it's 2 moles of aluminum for every 3 moles of zinc chloride. So 2 moles of aluminum goes on top, 3 moles of zinc chloride. I think I just called it aluminum chloride again. Kind of tired. I'm spacing out. But it is zinc chloride. So these guys cancel out. Moles of zinc chloride cancels. Moles of zinc chloride cancels. I'm ready to go ahead and do the math. So this, and I get 8 moles of aluminum as my answer. I can work on either the reactant side, or the product side. In the last problem, I had something from each side of the equation. In this one, I had something from the same side of the equation, and I could just as easily go over to the other side. In fact, you know what? Let me go ahead and do that. We'll work off of this same reaction. And get rid of some of this. And put some stuff back here. And that gets it 2. And I'm going to work off of the same reaction. Let's go ahead and get a new question here. Let's say we ask the question, how many moles of zinc are produced if 9 moles of aluminum chloride are made. Got my balanced equation up here. My recipe is up there. So my given is here, 9 moles of aluminum chloride. My unknown is the moles of zinc. I'm ready to go ahead and write out my setup. I've got 9 moles of aluminum chloride, AlCl3, and I'm trying to get to moles of zinc. My molar ratio, I'm going to box in the two things that I'm interested in. I am interested in aluminum chloride and zinc. Those are my given and my unknown material. You'll notice that it's the given material on the bottom. So it's the 2 moles of aluminum chloride on the bottom. Again, I'm getting this from my balanced equation up here. It's the coefficient that goes in here, right there. And on top is going to be the 3 moles of zinc. So it's my unknown over my given. Again, that comes from this part of the balanced equation. There's my coefficient. Ready to go ahead and cancel some stuff out and do the math. Moles of aluminum chloride cancel. I'm left with moles of zinc, which is what I was looking for. I'm ready to go ahead and do the math. And 9 times 3 is 27, divided by 2 is going to be 13.5. Pretty sure that's right. You know what? Let me just grab a calculator just for fun. So it's 9 times 3, hit enter, and divided by 2, hit enter, and yep, 13.5. My math was right. Just remember your molar ratios come from the balanced equation, and it's really just a matter of setting up the guess method after that.